5 minutes ago would have sounded impossible. An old spacecraft, farther than any human machine has ever gone, was still listening in the dark, still hearing something. Not a loud burst, not a crash, not a clear message, just a thin, steady hum where most scientists once expected almost nothing at all. And that matters to you more than it seems, because this sound is coming from the space outside the shield that protects Earth. Stay with this, because the deeper you go into Voyager 1's final mystery, the stranger the universe starts to feel. Voyager 1 was never meant to become the last active witness at the edge of the solar system. It was built for a mission that already sounded huge in the 1970s. Go to Jupiter, go to Saturn, send back pictures no human being had ever seen, measure worlds up close, then, if all went well, slowly fade into silence after doing far more than anyone had a right to expect. That would have been enough to make the spacecraft one of the greatest machines ever built, but Voyager 1 did not stop when the original mission ended. It kept moving, it kept surviving, and every extra year turned a successful planetary mission into something far more powerful. It became a living bridge between the human world and a region no one had ever reached before. To understand why this matters, you have to picture where Voyager 1 actually is. The solar system is not just a set of planets orbiting the sun. The sun also blows out a constant stream of charged particles called the solar wind. That wind creates a giant bubble around us known as the heliosphere. Inside that bubble sit the planets, the moons, the asteroids, the comets, and every human being who has ever looked up at the stars and wondered what lies beyond. The heliosphere is not a solid wall. It is more like a vast, moving bubble carved into the galaxy by the sun's energy. And at some point, that bubble ends. Its outer boundary is called the heliopause. Beyond that boundary begins the interstellar medium, the thin plasma, gas, dust, and magnetic fields that fill the space between stars. For decades, that region beyond the heliopause was more idea than place. Scientists had strong models. They had telescope data. They had theory. They had reason to think interstellar space near our solar system would be cold, thin, and fairly calm. Not empty in the total sense. Space is never truly nothing. But compared with the storms closer to the sun, the space between stars was often imagined as a sparse and quiet sea, a place with low density, slow changes, and not much local drama. Then Voyager 1 crossed the heliopause in 2012, and for the first time in human history, something built by human hands entered that region and started reporting from inside it. That changed everything. Suddenly, the universe was not just something we studied from far away. For the first time, we had a direct listener out there. Think about what that took. Voyager 1, launched in September 1977. It flew past Jupiter in 1979 and revealed a world far more violent and complicated than the old images had suggested. Then it flew by Saturn in 1980 and sent back views that reshaped planetary science again. It used gravity from those giant planets like a sling, trading a little of their motion for more speed. That trick pushed it outward faster than any earlier human spacecraft. It kept going long after its planned tour ended, long after engineers expected systems to fail, long after the people who built it had moved on or grown old. Its signal became weaker with distance, but it did not stop. Year after year, a machine carrying 1970s hardware kept whispering home from deeper and deeper darkness. Then came the crossing that changed its meaning forever. When Voyager 1 moved beyond the heliopause, it became the first object from Earth to enter interstellar space. That is one of those phrases people hear and nod at, but it is hard to really feel. Interstellar space is not just far away. It is the region between suns. It is the background ocean of the galaxy itself. Before Voyager got there, every model of that nearby interstellar environment had to be built from indirect clues. Even the best theories were still guesses tested against distant evidence. Now, for the first time, there was an actual instrument sitting there, listening, measuring, sending the answer back one faint packet at a time. At first, the story was already huge, just because Voyager could help measure plasma density beyond the solar boundary. Plasma is often called the fourth state of matter. It is gas with so much energy that electrons break loose from atoms, creating a soup of charged particles. Much of space is filled with it. Voyager 1 carries a plasma wave system designed to detect tiny changes in electric fields around the spacecraft. In simple words, it can hear the tremble of plasma. Before the strange hum was found, scientists mostly relied on strong solar eruptions to help measure this environment. Like when the sun blasted material outward, a shock wave could travel far enough to disturb plasma near Voyager, and the instrument could catch the resulting oscillations. That method worked, but it depended on luck. You had to wait for the sun to create the event, then wait even longer for that disturbance to travel all the way out to the spacecraft. What researchers did not expect was that Voyager 1 would also detect a faint, persistent signal, even when no major solar shock was passing by. In 2021, scientists led by Stella Koch-Ocker at Cornell reported that Voyager 1 had detected a narrow-band, steady plasma emission in interstellar space. It was not dramatic in the way movies train you to expect. It was not a sudden blast. It was not a coded transmission. It was subtle, weak, monotone, almost easy to dismiss if you wanted drama more than truth. But that is exactly why it shook people who understood what they were seeing. Real mysteries in science often arrive quietly. This one appeared as a constant low hum in the interstellar plasma itself. The team described it carefully. They did not claim a miracle. They did not claim a signal from another intelligence. They said Voyager 1 was detecting a faint, persistent hum of interstellar gas. James Cordes, one of the researchers, used a beautiful comparison. Solar eruptions were like lightning in a thunderstorm. This constant signal was like a gentle rain. That image matters because it explains how different this was from the old way of measuring the region. Instead of waiting for rare violent events, scientists now had evidence of a constant background process. Voyager could keep telling them the density of the plasma around it without needing the sun to throw another punch. That meant the spacecraft had become more than a distant probe. It had become a continuous monitor of the space between stars. And here is where the mystery starts to open wider. Once researchers looked closely at the data, the old picture of interstellar space as a smooth, calm, near vacuum began to crack. The signal implied that the local interstellar medium had more low-level activity than expected, more texture, more structure, more subtle motion. The region around Voyager 1 did not behave like a silent blank. It behaved like a place, a real environment with ongoing plasma behavior that had not been directly seen before. That does not mean every old theory was wrong. It means some theories were incomplete. The difference matters. Science rarely flips from truth to total falsehood in one clean jump. More often, it sharpens, it deepens. It shows that the simple sketch was only a first draft. If you were one of the scientists on that team, what would your first reaction be? Excitement, maybe, but also fear. Because the moment a result begins to challenge the old picture, you have to ask the hardest question first. Is it real? Is this signal really coming from space, or is the instrument fooling us? That is the discipline behind the wonder. This was not a new spacecraft with modern systems and endless bandwidth. Voyager 1 was already ancient by then. Its systems were old, its data rate was painfully small. The instrument doing the listening was never designed to still be active after nearly half a century, so researchers had to be patient, careful, brutally honest. They had to separate what the spacecraft truly heard from what people wanted it to mean. That is why this story matters so much. The mystery survives because the science is serious. The signal was reported in a peer-reviewed paper. The wording stayed cautious. The interpretation stayed open. What scientists could say was that Voyager 1 appeared to be measuring persistent plasma wave emission in interstellar space from 2017 onward. What they could also say was that this new signal offered a way to track plasma density continuously. That alone was a major shift. It meant the interstellar medium near Voyager was not only measurable through rare solar shocks, it had its own background voice. But then came the harder question. What exactly was making that voice? One possible answer is thermal plasma oscillation. The phrase sounds heavy, but the idea is easier than it seems. In plasma, charged particles move because of heat and electric forces. Under the right conditions, they can produce natural oscillations, tiny organized vibrations that show up as a signal. If that is the main explanation, then the discovery still matters a great deal. It would mean the interstellar medium has a persistent, detectable baseline activity that lets us track its density in ways we could not before. It would confirm that the region beyond the heliopause is more alive with subtle plasma behavior than the old simplified picture suggested. But there is another possibility that keeps this story from settling down. Some scientists connect the signal to quasi-thermal noise. Again, the words sound technical, but the heart of it is simple. In plasma, electrons are always moving and jostling, and those tiny motions create faint electric fluctuations. Under some conditions, those fluctuations can be measured as noise that actually carries information about the plasma itself. If that is what Voyager 1 is mainly hearing, then the implications could be deeper. The signal would not just show that the medium is active, it could provide richer clues about density, temperature, and local conditions in that interstellar plasma. It could mean scientists need to revisit how they interpret some of the environment beyond the heliosphere. And this is the key point. Years after the hum was first reported, scientists still had not fully closed that argument. One mechanism may be contributing, the other may be contributing too. Both could be mixed together. That is not a weakness in the science. It is science doing exactly what it should do. It refuses to fake certainty. It lets the evidence stay difficult until the evidence becomes stronger. The universe does not owe us easy answers. It gives us data. Then it watches what we do with it. But here is where things get even more intense. The uncertainty is not just about physics, it is about time. The only machine sitting in that environment is old, fragile, and running out of power. So this is not a mystery that can wait forever. The clock is part of the story. Before we get to that clock, there's another part of the mystery you need to feel. The heliosphere is not just a scientific boundary, it is also part of Earth's cosmic protection system. The sun's bubble helps shield the solar system from some of the harsh galactic radiation flowing through interstellar space. Earth has its own defenses too, especially the atmosphere and magnetic field, but the heliosphere is the outermost giant layer in that chain. So, when Voyager 1 tells us that the region pressing against the heliosphere is more structured and more active than expected, that matters beyond pure curiosity. It does not mean danger is suddenly rushing toward us. There is no evidence for that. But it does mean our understanding of the boundary protecting the solar system may have been too simple. That boundary now looks less like a clean wall and more like a living frontier. Earlier studies tied to Voyager data suggested that the magnetic field just beyond the heliopause was not flipping into a neat, untouched interstellar pattern as quickly as some researchers expected. Instead, the region seemed distorted, shaped by the interaction between the solar bubble and the galaxy outside it. That is a powerful image. It means the edge of home is not a line drawn with a ruler. It is a meeting place, a zone where pressure, particles, and magnetic fields push against one another in ways we are still trying to understand. And that leads to a question that should make you stop for a second. If the boundary around our solar system is more complex than we thought, how many of our broader ideas about the local galaxy were built on pictures that were too smooth, too quiet, too simple? That is the kind of question a discovery like this opens. Not panic, not fantasy, just a deeper level of humility. If you were the scientist staring at those faint frequencies arriving from more than 15 billion miles away, would you trust the signal, or would you spend months trying to prove yourself wrong first? That is the human part of this story. It is not just about space. It is about how hard it is to let reality get bigger than the models we built for it. Voyager 1 kept forcing that reality to get bigger. The spacecraft moved farther outward. The signal kept coming. And at the same time, the machine itself began to show its age in painful ways. A few years ago, engineers noticed that Voyager 1 was still transmitting to Earth, but the data made almost no sense. The spacecraft was talking, but what it said looked like gibberish. Imagine the stress of that moment. A dead spacecraft is tragic. A live spacecraft speaking nonsense is worse in a different way because it means something inside is broken, maybe repairable, maybe not, and you have to diagnose it across a gulf so large that even light needs almost a day to cross it. Eventually, the team found the cause. A memory chip in the flight data system had failed. That chip helped store the code used to package and format the probe's science and engineering data before transmission. One damaged piece of hardware, after decades in deep space, was enough to corrupt the whole data stream. There is something almost brutal about that. This mighty mission, this machine that crossed the solar boundary and entered interstellar space, could be pushed to the edge by a single bad chip. Now imagine the repair job. On Earth, you would replace the component. In a near-Earth satellite, maybe a servicing mission could someday help. But Voyager 1 is too far for anything like that. A command from Earth takes roughly 22.5 hours to arrive. The reply takes just as long to return. Every test cycle costs nearly 2 days. Every command has to be crafted with care because a mistake cannot be undone quickly. Engineers had to figure out how to move damaged software sections into different areas of the spacecraft's memory, rewrite the way those sections linked together, and then slowly wake the system back into readable operation. It was like rebuilding part of a mind through a whisper sent across almost 2 full days of silence. Against the odds, it worked. Voyager 1-1 resumed sending usable engineering updates. Later, it resumed returning more science data. That success is one of the great quiet rescue stories in the history of spaceflight. But it also revealed something painful. This mission is no longer living on normal margins. It is surviving on miracles built from skill, patience, and luck. And then came another warning. Earlier this year, Voyager 1 went through a routine roll maneuver meant to help keep communication aligned with Earth. During that process, power levels dropped unexpectedly and came close to triggering the spacecraft's undervoltage fault protection. That is the kind of automatic system designed to protect the spacecraft when electrical power gets too low. If it had fully tripped, the recovery could have been long and uncertain. NASA engineers decided to act before things got worse. In April, they shut down the low-energy charged particles instrument on Voyager 1 to conserve power. That instrument had been operating since launch. Turning it off was not a simple housekeeping move. It was one more sacrifice made to keep the spacecraft alive. To see how serious that is, you need to understand how Voyager gets its power. It uses radioisotope thermoelectric generators. Those devices turn heat from the decay of plutonium into electricity. At launch, the power supply was enough to support a healthy package of science instruments and spacecraft systems. But radioactive decay is steady, and the system loses output over time. NASA says each Voyager spacecraft loses around 4 watts of available power every year. 4 watts. Does not sound like much on Earth. In deep space, it is everything. It is the shrinking margin between one more year of science and the permanent end of the mission. This is why the decisions have become so hard. Long before the latest power emergency, engineers had already shut down instrument after instrument to keep the spacecraft alive. The cosmic ray subsystem was turned off. Other systems went dark. Bit by bit, the rich scientific toolkit launched in 1977 has been reduced to the bare essentials. Now, Voyager 1 is down to just 2 active science instruments. One is the magnetometer, measuring magnetic fields. The other is the plasma wave system, the very instrument responsible for detecting the mysterious hum. Think about that. The spacecraft that found the mystery is now essentially preserving the 2 senses, most tied to that mystery, while everything else fades away. And that changes the emotional meaning of every transmission. Each packet of data is no longer just another scientific update. It is a last chance. A little more evidence from the only listening post we have beyond the heliopause. That gives the mission a strange tension. Scientists are not just studying space, they are racing against the slow death of the only witness close enough to help. There is a plan to buy more time. NASA has been testing a bold power-saving strategy nicknamed the Big Bang. The idea is to swap out or reconfigure older power-hungry electrical pathways in ways that could preserve operating margin for the spacecraft. Voyager 2, which is somewhat closer and has slightly more room in its power budget, is being used first as the safer test case. If the strategy works there, engineers hope it can help Voyager 1 as well. That matters because even a modest extension could keep at least one instrument alive into the next decade. But the word hope is doing a lot of work in that sentence. This is old hardware. The mission is operating at distances no one planned for. Every change carries risk. Every gain is hard won. And all of this is happening as Voyager 1 approaches another milestone that feels almost unreal. Later this year, the spacecraft is expected to reach a distance of 1 light day from Earth. That means a signal moving at light speed will need a full 24 hours to cross the gap. Sit with that for a moment. A human machine built in the 1970s will be so far away that light itself takes a day to get back from it. No object made by our species has ever gone farther and still remained in contact. That milestone is thrilling. It is also cruel. Because while Voyager 1 breaks records, the mission team knows the end is coming. There's no way to refuel it, no way to add power, no way to swap old hardware for new hardware. One by one, systems will continue to go dark. Science instruments will be shut down to save the core spacecraft. Eventually, there will not be enough power left to keep the remaining instruments running. After that, even communication itself will fail. When that day comes, Voyager 1 will not explode. It will not announce some grand farewell. It will simply become silent. And when it does, the mystery it raised may go silent with it. This is the part of the story almost no one fully absorbs on first hearing. There is no replacement spacecraft waiting nearby. There is no funded mission ready to arrive in interstellar space soon and continue the work. Even if a new probe designed specifically to study the local interstellar medium were approved tomorrow, built fast, and launched on an ambitious schedule, it would still need decades to reach the region Voyager 1 is exploring now. That means the data stream we're getting is not just rare. It is unique. When it ends, an entire kind of direct measurement ends. With it, maybe for a generation. That puts enormous weight on the unresolved hum, because the 2 broad explanations still matter. If the signal is mainly thermal plasma oscillation, then the interstellar medium around Voyager is confirming a continuous kind of plasma behavior that gives us a powerful new tool for tracking local density. That alone would still reshape how scientists think about the region outside the heliosphere. But if quasi-thermal noise plays a major role, then the signal may carry deeper clues about the fine structure of the plasma itself. It could help reveal more about electron behavior, local temperature, and the detailed physical nature of the medium. Either way, the discovery is important. But the difference between those explanations affects how much has to be revised in our larger picture. And remember, these are not arguments built on fantasy. This is not internet mythology pretending to be space science. These are real researchers trying to interpret a real signal in peer-reviewed work. That is why the story feels heavier than the usual deep space headline. It is grounded. There is no alien claim to hide behind, no made-up object, no secret-coded message, just a measured physical phenomenon and experts still trying to pin down what it means. In a strange way, that makes it far more exciting. Anyone can invent nonsense. Very few missions get close enough to reality to find a mystery that reality itself refuses to settle. Around this point, some people ask the obvious question, why should anyone outside astrophysics care? The answer is scale, not just physical scale, but human scale. Voyager 1 is helping answer one of the oldest human questions in a new form. What is it actually like beyond the edge of what we call home? Not in poetry, not in theory alone, in measurement, in numbers, in signals, in the texture of the plasma itself. That matters because every human map starts as a story told from inside the campfire circle. Then one day someone walks farther than anyone before and comes back saying the land beyond is not what we thought. Voyager 1 is that traveler. The emotional force of the mission comes from that role. It is easy to say the spacecraft is old. It is harder to say what that age means. This machine was built before smartphones, before home internet, before most modern software, before most of the people watching this story were even born. Yet it is still doing first of their kind science in the space between stars. Its data has already helped confirm that the local interstellar plasma is denser than the region inside the heliosphere. It has helped show that the magnetic transition at the heliopause is more subtle than some expected. It has now revealed a persistent hum that suggests ongoing low-level plasma behavior beyond the solar boundary. This is not a relic drifting in glory. It is an active explorer, still changing the map. And there is something haunting about the fact that the explorer is doing this while so close to the end. The mystery was not found by a fresh mission entering a long science phase. It was found by a spacecraft in its final years, working with tiny margins, barely able to keep all the right systems alive. That changes the tone of the whole story. Every new clue comes with loss. Every new measurement comes from a machine already giving up parts of itself to keep going. One instrument goes dark so another can stay alive. One power-saving trick buys a little time. One repair patch rescues a failing system. This is not just science, it is endurance. If you could choose one answer before Voyager 1 finally falls silent, what would it be? Would you want the team to prove exactly what causes the hum? Would you want them to map the magnetic field farther out? Would you want them to push every remaining watt into the plasma instrument and chase the signal until the very end? There is no perfect choice, because every choice is now about trade-offs. That is what makes the mission feel almost human. Aging is built into it, limits are built into it, and still it keeps going. The bigger picture is even harder to ignore. The universe is often presented as if it has already been neatly organized by modern science. Planets here, stars there, black holes over there, dark matter somewhere in the background. But missions like Voyager remind us how little direct contact we have with most of reality. We infer more than we touch. We model more than we sample. We imagine the dark between stars using equations and remote observations, because almost none of our machines have ever been there. Then one ancient spacecraft crosses the boundary and suddenly the picture gets messier. The calm void turns textured. The sharp border becomes a living frontier. The silence becomes a hum. That should make you feel two things at once. Awe, because we built something capable of reaching that region and still speaking to us. And humility, because the first direct whisper from that region is not a clean answer, it is a puzzle. It is a reminder that the universe does not become simple just because our models become elegant. There is also a deeply personal side to this if you let yourself feel it. Every human who has ever lived was born inside the sun's bubble. Every memory, every city, every war, every song, every child, every telescope, every prayer, every story we have ever told has happened inside that moving shield. Voyager 1 crossed beyond it. It went outside the front door of the only cosmic neighborhood we have ever known and turned back toward us with data in its hands. The first things it told us were already historic, but now one of the last things it may tell us is that the medium outside our shield is more alive and more complicated than we imagined. That is not just information, that is perspective. And maybe that is why the mystery hits so hard. It comes from the farthest working object humanity has ever made. It comes from a place no person has seen with their own eyes. It comes through a spacecraft so old and fragile that every recovered bit of data feels like a gift. It comes in the form of a soundless sound, a plasma hum in the dark, a clue so faint you could almost ignore it if you did not know what it meant. Yet serious scientists did not ignore it. They leaned in, they measured it, they argued over it, they published it, and years later they still have not finished unpacking it. That is the difference between a headline and a real cosmic story. A headline wants a shock. A real story gives you a question that stays alive after the first thrill fades. Voyager 1 has done that again and again. It did it at Jupiter, it did it at Saturn, it did it at the heliopause, and now, in what may be the closing chapter of its mission, it is doing it with a quiet hum in interstellar space. One day, maybe in the early years of the next decade, Voyager 1 will stop sending data. The power will drop too. Low. Another system will fail. Another instrument will go dark. The antenna will no longer be able to hold the whisper steady. And the last message will come home without anyone knowing it is the last until the silence stretches too long. That silence will not erase what the spacecraft found, but it will freeze the mystery in place. The question will remain, waiting for some future mission that does not yet exist to travel out and ask the universe again. Until then, this old machine is still listening, still measuring, still telling us that the emptiness between stars may not be as empty or as simple or as quiet as we once believed. And maybe that is the most powerful part of all. The universe did not reveal this with a blaze. It revealed it through patience, through persistence, through an instrument old enough to have every reason to fail and still working anyway. Sometimes the greatest discoveries do not arrive like thunder. Sometimes they arrive like a low, steady hum from the dark just beyond the edge of home. So here's the question I want to leave with you. If the last surviving ear in interstellar space is hearing something we still cannot fully explain, what else is waiting out there in the quiet that we have never had the chance to hear at all? Tell me what you think. And if this is the kind of cosmic mystery that keeps you staring into the night a little longer, stay with Galaxy Sphere, because the next clue may come from the edge of everything familiar. NASA's Voyager 1 2026. Mystery. Why is there a hum beyond the solar system? Before Voyager 1 goes silent, NASA may solve its strangest interstellar signal. Voyager 1 detected a steady sound in deep space, and scientists still can't explain it.